We can start already. Good morning again to everybody. The next talk is going to be with Simon Riggs. Simon is the CTO and the founder of Second Quadrant. He is one of the great guys that is with Postgres since the beginning. And Simon is going to talk about replication in Postgres and 9.6, 10, and beyond. Thank you, Simon.
Thank you very much. Well, it's certainly always a pleasure to come to Italy to speak. You always give me a very good welcome, so thank you very much. I'd like to thank the organisers for doing such a good job because, again, the conference has got bigger like it has done every single year, so I can barely see the people at the back of the room. The room is now so big from like where we did this a few years back, where it was just a small room full of 10 or 20 people, and now we've got nearly 200 people, so that's brilliant. What I'm going to talk to you about today is replication. I hope you can hear me and understand my English. There's lots of people that can interpret if you don't. So what I'm going to talk about is the whole subject of interoperability between databases. And PostgreSQL is designed to be a general purpose database for OLTP, business intelligence, and various usage. And it's very important that it fits within the strategy for your enterprise. So we don't assume that you have just one database. We assume that you're going to want lots of databases and that you're going to want to link them together, not just for high availability, but for lots of other purposes as well. So what this diagram shows is the concept that you have lots of Postgres databases, or if you don't, you will. And you also have some other databases in your enterprise. And the concept is that we want to link all of those databases together using Postgres technology. And what we're able to do with Postgres is either push the data to other systems using replication, but also pull the data from other systems using remote data access technology. And in Postgres, we call those foreign data wrappers. Now that's a strange term, and you may think, why did we call it that? That's because that term is, comes to us from the SQL standard. So we have used exactly similar terminology from the SQL standard, and we've used all of the interfaces as defined. So we're probably the only database that supports a fully standardized way of accessing data. Now, what Postgres provides is something called Postgres FTW. So if you look at, say, Oracle, when you set up a database link, you can set up an immediate link between two databases. In Postgres, you have to load the extension to allow you to access other Postgres databases. Now, in some systems, eventually, that will be loaded automatically, but once it's loaded, you can then just use that functionality as if it was native functionality. So what this allows you to do is create direct access links to other systems so that you can bring data back from those systems, but you can also write to those other systems if you need to as well. Now, in Postgres 10, the way this works has been substantially improved. It was improved in 9.6 as well, and actually it's at the stage now where it's fully usable in production if that's what you need. Now, I said that it's possible to write to those data sources, but I have to say it doesn't work that well, and that what you really want is some form of push technology that allows you to make the writes locally and then have those have that data flow to another system. And that's what I'm going to talk about for the rest of this presentation, is replication and data integration. So as of 9.1, which is now more than 5 years ago, we introduced streaming replication that allowed synchronous replication as well as asynchronous replication. So for the first time, we were able to create a configuration that had essentially zero data loss. In 9.6, we introduced the concept of being able to write to multiple systems at the same time. So this is what we call K replication, in that we can specify the number of nodes we want to send data to. Now in 9.6, that syntax was specified like this, where we specify the number at the front, and that's the number of copies of the data that we want to make. And in 10, that was extended further, because in 9.6 we had the capability to copy to a number of systems, but it always did the same systems. So first of all, it would do node 2, then node 3. In the current system, in Postgres 10, you can specify any two out of a group. So if one system is slow and you get replies from other systems, then it will be safe quicker. So the purpose of the feature in Postgres 10 is to reduce the latency if you have network jitter to remote systems. So this gives you much higher levels of safety. So you're able to specify the number of copies of the data that you would wish to make. So that's a further extension to the robustness of Postgres. Now this applies at the moment to physical replication, but it's also possible to do this with logical replication. In Postgres 10, we introduced a feature to track the lag time in replication. So for the first time, we've actually got a mechanism that allows us to tell, in terms of time, how far behind the nodes are. We were able to track that in 9.6 and earlier by tracking the amount of replicated data that was waiting to be applied, but there's a difference between the amount of data and the time taken, and that's what the replication lag feature now gives us. So for the first time, we can draw accurate time graphs of exactly how far behind the replication is. Now this has been designed in such a way that it works for both physical and logical replication. How am I doing? Am I making sense for everybody? Put your left hand in the air if you understand me. Okay, cool, good. No, Karen, left. So Postgres 10 has got quite a few features for recovery and reliability. There's some improvements to the hash index that allow that to be well logged. There's actually a tool for WAL consistency checking now. So we've completely overhauled the test framework for Postgres 10. So for the first time, we have a very thorough test framework for the replication itself. So that's quite a good step forwards. We've introduced a few more features, but one of the most important things we've introduced is a feature to improve the latency of physical replication in certain edge cases that were annoying us. So I'm very pleased that we've been able to get that last feature in, because it makes a big difference to the robustness of Postgres replication. So we have the capability then in Postgres to have streaming replication between sites and within a site. So this allows us to make standby copies that we can use for read scalability to make the cluster grow fairly large. And there's many people using this that have 10 or 20 standby nodes, in some cases more. We also have the ability to replicate to remote locations and cascading that allows us to minimize the bandwidth between sites. That's physical replication, and what we've been working on in recent times is logical replication. the idea that we can send data to another master. And as a result of that, we can actually do quite a few different applications that we weren't able to do before when we just had physical replication. So logical replication is designed to address the need for data integration, so we can push data to downstream systems. So this specifically allows you to adopt a microservices architecture with your data integration built using solely PostgreSQL components. And that's very important. So we're able to push the data wherever the data needs to go to. So that allows us to have a system that pushes reference data from a single system where we keep track of that reference data, and we can push that out to a number of other servers. So I call that a rollout system. What we also want to do is a roll-up system, where we take the data from multiple different systems and roll it up to a central location. And what we actually want to do is all of these use cases all at once. And that's the technology that we've been building, is something that will allow you to do all of these cases all at once. So Postgres 10 has logical replication built in now. We've introduced DDL objects that allow you to create a publication, and then you can have multiple subscribers to that publication. So we describe this as a publish and subscribe model. So you create the publication, and then when you add subscribers to it, the initial system doesn't need to know how many subscribers do you have. Now this allows you to very carefully control the security of your applications, because you're able to expose only some of the data. You don't have to expose all of the data. So that this allows you to say, I want tables A, B, and C to be sent through to a remote system. And on the subscription side, you can choose which publications you're going to receive. Now, DDL is not managed automatically yet. You need to do that yourself, but we do have hooks in place, and it's certainly going to happen in the future that would all be managed automatically. We're just not there yet. The main reason for that is DDL replication is way more complex than it sounds, because of the vast range of different commands and all the different things that those commands do. So we need to do that without introducing lots of bugs. So we will be taking small steps forward in that. It won't happen all in one big bang. So now that I've thoroughly confused everybody with all of these different options, the question is, which replication do I use? What is the difference between physical and logical replication? Well, physical replication is really designed for high availability. It's been there for years, it works really well now, and we have no intention to have you stop using it, okay? It works. Logical replication is designed as an additional capability, an additional feature, which gives you new things that you couldn't do before. So you can do application integration, you can do online upgrade, for example, between release levels, and we're also trying to integrate in core the capability to do multi-master database as well. And these are some of the things that I'll talk to you about now. In terms of logical replication, that is also a little bit more complex than I've explained. The sending side is already built into Postgres 9.4 and above. So if you're running 9.4, 9.5, 9.6, or 10, you can send data to a Postgres 9.6 or 10 system. So the sending and receiving sides can be different release levels, okay? Now, there's also a slight difference between the logical replication that's built into Postgres 10 and the replication that you can get using a tool that Second Quadrant publish as open source called PGLogical. Now, we've just released the version 2.2 of PGLogical. So how do you choose between using Postgres 10 logical replication and PGLogical? Well, the concept is that we build things first in PGLogical and then we release them into core Postgres. So PGLogical will always be slightly more advanced than the features that we have within core Postgres. In Postgres 10, you have the ability to use the create publication, create subscription commands. Now, the same concepts exist in PGLogical, but instead of a DDL command, we just use a function to create publications or subscriptions. PGLogical 2.2 has got some additional performance tweaks, and it's also got the ability to filter the rows. So Postgres 10 allows you to filter the tables. PGLogical also allows you to filter rows. We are working on PGLogical 3, and that's got some important new capabilities in performance. And it also has things like a Kafka interface, and it will also have many additional interfaces as well. So that is an important new architecture that we will be releasing in the near future. Not sure exactly what the release date for that will be. So there are actually different flavors of logical replication. So one of the most important things that we can do with PGLogical is upgrade your systems. You'll be able to move from one release of Postgres to another with almost zero downtime. Now, our first customer to do that reported that they were able to move from one release to another with 7 seconds of downtime. And I think that that is very good. 7 seconds is comfortably within what we call 5 nines availability, which requires us to have no more than 26 seconds of downtime per month. So we're comfortably able to give 99.999% availability using this system. So all of the things that we're working on here come out of a project called BDR, and we're feeding that back into Postgres core. We started the process of building it a long time in the past, and we've been feeding things back into core Postgres every release now for the last 5 separate releases. So as of now, the project's taken, the project's entering its 6th year of development now. And we've been feeding things back into open source Postgres every single year. So that is actually going to continue for at least another 3 releases, probably more. I say 3 because I simply can't even imagine what things we'll be writing in the future, but that's okay because users are able to tell us all of the different things we need, and then we build that into the system. So what does BDR do, and why is it called BDR? So the concept is that BDR stands for bi-directional replication. The idea is that you'll be able to send changes in multiple directions, and what that gives you is the ability to produce multi-master. Now, why do we need multi-master? Well, if you only have a single master, then wherever that master is in the world, you have fast access to it from the local application server. But if you've got an application server in a different part of the world, then applications are going to go very slow to it. Now, in this particular slide, what I'm talking about here is 2 databases, one on the east coast of America and one on the west coast of America. Now, America is so wide that the ping time between that the sides of America is long enough that you would notice as a human while that wait takes place. Now, if America's big enough that that's true, then certainly any application that you have that exists, say, in Italy and London, or certainly Italy and anywhere outside Europe, the ping time between those sites is so high that your users will notice the difference. So if you're running any kind of international application, you're going to get very poor performance and user noticeable poor performance, which is obviously very important. So what we can do with multi-master is we can set up a cluster where every user connects to a local node, wherever they are in the world. And that means we're able to create global applications that are able to reduce access time to data and increase the utility of that for the user. So Postgres BDR is multi-master Postgres. The currently available system has got the Postgres license. The on-disk data format is exactly the same as Postgres, and there's a number of different features here. It's a very well thought through system. It's got advanced production controls that allow you to make practical use of it. It's not just a theoretical system. In fact, Postgres BDR has been in production use for more than 3 years, okay? So there are many people using it worldwide for multiple years now. It works, it's viable. Postgres 1 is fully available as open source, and we've said that we would support that for 5 years. Postgres 2 is available as an extension on 9.6. Now, this is not available as open source at this time. And some people have said, oh, right, so you've stopped being open source guy now, have you? You're restricting access to it, you evil man, okay? Well, you know, okay, that's a nice thought. Thank you for the comment. What happens is that if we release software, we have to support it, and that costs money. And what we're choosing to do is a conscious choice in terms of resource allocation is rather than release some software that we think is going to be replaced fairly quickly, we're dedicating that time onto the next version of Postgres BDR, version 3. Now that will be open source, so rather than release 2 and then have to support it for 5 years, we're spending that time that we would have spent supporting that on releasing BDR 3, which will have much better features and that we will support as open source. Okay, so it's a conscious resource allocation decision so that we can bring you the best things more quickly rather than you know, support some software that as soon as you see it, you'll go, well, where's version 3? Okay, is that clear? I mean, I'm happy to talk to people about that afterwards. There's no doubt that all of this is open source. I think that's very important. That's what our customers are telling us is important. But we can't do everything, right? So we have to make some choices about how we proceed. Okay, with that being said, I'll move on to my next topic, which is very large database. And it's clear that if we want to support a use case where we bring in lots of data from an edge network into a central system, we're going to end up with a lot of data. Now, these logical systems support literally hundreds of nodes. So we have a customer that is connecting literally hundreds of nodes. Does anybody know exactly the number of nodes of the customer I'm talking about? 250? 250 nodes. So this is designed to have a very large number of data collection appliances. Now this cascades, so what we're saying is one central node has got 250 nodes pumping data into it. So if cascading works, each of those nodes could also have 250 into it. So we'd have 250 squared, which is quite a lot of nodes. So how do we do that? Well, we're building something called PostgreSQL. It's already available as open source software. PostgreSQL 9.5 is available now, and it provides MPP and OLTP use cases. What we're working on now is PostgreSQL 10. PostgreSQL 10 is now in alpha and will be expected to go production next year. What PostgreSQL allows you to do is have a scalable system where you can add nodes to expand your database. So you can actually have a much larger database running on PostgreSQL than you can on Postgres. So the limits of this type of system go up into the hundreds of terabytes or even petabytes. Obviously, doing benchmarks on petabyte scale systems are enormously expensive. So we haven't actually run this system up to the largest scale possible to see how far it goes. But clearly, it goes up so far that we haven't been able to measure how big a database we can run it on. So PostgreSQL running with Postgres 10, so that's with full partitioning, parallel query, those kind of features, is in alpha now, fully open source, and we're going to be moving into production with that later in 2018. So the options that we have for distributed PostgreSQL are PostgreSQL, in that we're able to build very large database systems, and then we have logical replication, which allows you to pump data between systems, and these have been designed to work together so that PG Logical can pump data from Postgres systems into a PostgreSQL database. And lastly, Postgres BDR gives you the option of multi-master databases. So taken together, we've got a full set of software that gives you all of the architectures that you might want to build in enterprise systems. So PostgreSQL for large databases, and Postgres itself for small to medium and large databases. So what we are pursuing is a code strategy of developing solutions now so that you can take advantage of them in the real world, but then pushing those changes back into core Postgres. And this is a strategy that we've been pursuing for more than 5 years now, slowly pushing things back into the core of Postgres. That's what our users want to see, and that's what we're making happen. So we feel that that's the right way to do things, because it can take quite a few years to get the Postgres community to accept certain approaches. For example, the community required us to completely rewrite PG Logical before it was submitted to Postgres 10. So obviously that type of thing takes time. So what I'd like to do now is just give you a quick demo of something else that we've been working on, which is called OmniDB. And OmniDB is an alternative GUI for PostgreSQL, but the reason it's called OmniDB is that we've designed it in a way that it will support other databases as well. So the whole idea here is that it will allow you to run MySQL and Oracle and SQL Server applications in the one common interface. Now, one of the things that we've tried to do there is to make sure that the PostgreSQL compatibility is really good. We're not trying to diminish the capability for MySQL or anything, but we want a tool that's very good with Postgres, but also capable of managing other systems. I'm not sure if you're aware, but there's been quite a few complaints about the quality of PGadmin 4, and that's led to the development of OmniDB. Now, one of the things that I could show you briefly here, I'm not sure that some of the people at the back can see, is that we can actually use this to monitor replication, and we can also use this to monitor, to create publications and subscriptions. So if you look at the tree view just here, you'll be able to see that it directly supports logical replication with publications and subscriptions, and you can view replication slots, and you can also ask the system to show you monitoring statistics on replication. So what we have with OmniDB is a graphical user interface that allows you to manage PostgreSQL, but not just basic PostgreSQL. It allows you to manage the full replicated versions of Postgres. So all of the things that we're producing, like PGLogical, Excel, and BDR, will be managed via this interface. So it allows you to roll out this application to a wider team of DBAs to allow you to manage those systems with a graphical user interface. So I was going to give a demonstration, but I think it's clear that there's not enough people can see the screen well enough for me to do that. So what I'd like to do slightly earlier than the normal is just stop for questions about some of the things I've talked about. Either Postgres Excel or Postgres BDR or PGLogical or anything like that. So could I ask for questions, please?
Hello, thank
Hello.
you for the presentation. Any comment, suggestion, or whatever on conflict resolution on multi-master replication? In case the same record is updated at the same time, more or less, on two different master nodes.
Yeah, so what we're building into BDR3 is the ability to have consistency options of either efficient or eager. And what that means is that you'll be able to decide how consistency should be handled in the case that you make changes in different places at the same time. So in one case, for efficient operation, we make the changes locally and then send the data to the other nodes, which can cause a conflict. The other way of doing it is eager, where we make the change, but we don't allow the commit until we're certain that the change can be made everywhere. So you will have the choice of either very efficient or eager, which means very highly consistent operation. Obviously, the best applications to run multi-master are ones that do not have many conflicts. And obviously, this sounds like a strange restriction, but in fact, when you look at it in the real world, most applications do have a natural way of writing them that avoids conflict. So if you look at the theory of multi-master in the general case, it sounds difficult and complex, but in practical terms, it works very nicely in the real world. And as I said, we've got customers using it for more than 3 years that are extremely happy with the way it works, able to run that successfully in production. So it is definitely the future. If you'd have asked me that 10 years ago, I'd have said, no, it's going to suck. But the reality is that it does work quite nicely in production. So, thank you. There was another question here.
So obviously I have a... Okay. Do you think it's feasible to make any assumptions on the date when Excel could go into the core?
Excel into core? Well, I guess we're going to try to put some things from Excel into core, but it's really in its current state, it's too big to go in one patch. So I think it could be some years before that functionality appears fully in core. Some people would claim that some parts of it are already there, but I think we'll have to see. Typically, the Postgres community has been very careful about accepting new features, so it takes time to put those new features into core. So unfortunately, it will be some years yet before we see some of these features fully in core, and it could be as many as 5 years.
Thank you.
One of the things I recently blogged about, by the way, was the fact that somebody suggested that it was a really good thing that MySQL had fixed a bug, and they said which bug it was. I don't know if you've seen the blog, and I wrote a blog about this because that bug had been open for 14 years in MySQL, and I said, there are no bugs in Postgres that have been there for like more than a month, really, let alone 14 years, okay? And it's a completely different approach to robustness, okay? We understand that people use Postgres because they kind of like their data, right? And if you can't trust a database to look after your data, then you don't trust it at all. So we place trust and data protection very, very highly within the PostgreSQL community, and that's why it takes so long to get changes into Postgres. So other databases may have some features faster than Postgres does, but you can be assured that when Postgres puts a feature in, it's robust and ready to use. And I think that's a very important distinction. So while I'm telling you bad news about how long things take to get into Postgres, please understand that the very highest quality, like a good wine, takes a long time to mature, or a good whiskey, I should say. Sorry.
So my question is, how do logical replication and physical replication match? I mean, on the publisher side.
So logical and physical replication are designed to work together on the same system. So you can have them working side by side. It's not a problem at all. So both physical and logical replication work by using the transaction log. Physical replication uses the transaction log directly, whereas logical replication translates or decodes the transaction log into a more logical form that allows it to be easy to use. So they're both very efficient mechanisms, and they're designed to work side by side. And most importantly, they're not just designed to work side by side, but they're designed to work in extremely similar ways. So if you look at PGStat replication, it will tell you the statistics for all of the replicated connections that you have on the system. You don't need to do one thing for physical replication and one thing for logical. So they're designed to be as similar as possible. Okay. Did that answer your question? Or please ask again if there's a...
Sorry, I wasn't clear enough. The fact that when the master switches to...
Yes.
Okay, when it switches to, when we have to switch master to a standby, what does it happen on all the subscribers to the original master? I mean, you have a logical replication in place in a network, and your main publisher switches to backup.
Yes.
What does it happen to the subscribers? Thank you.
Yeah, at the current time, failover for logical replication doesn't work fully in core. That was a deliberate choice that some of the developers wouldn't allow that feature to be committed into the repository. So unfortunately, that's not available in Postgres 10. For second quadrant customers, we have that feature available. We submitted it as open source, it just wasn't accepted. So we're able to run that for our customers if you need that feature.
Okay. I have one there first.
Hi. So am I correct assuming that streaming replication is cluster-wide, whereas logical replication is per database, right?
Yes, it's per database, but you
Okay.
can also select per table.
Okay. So my question is, if I have a cluster with, let's say, 100 databases, and I have a use case for using logical replication, how efficient or not would it be to...
Well, there's not really a loss of efficiency because of it working at database level, but what will happen is that each replicated link needs one connection, so you will need 100 connections if you have 100 databases. Now, we did try to come up with a design that didn't do it per database. We tried to do it at the full table level. Now, the difficulty with that is that it didn't work well with catalog changes and security. And as a result, we had to make it work for the database, at the database level, which then does cause people with lots of databases a bit more of a problem. So I'm sorry about that. We did try, but weren't successful to get the community to accept that design. So,
Thanks.
We are right on time, and sorry if we have more questions, but we are going to be outside, so Simon is going to be there. And if anyone has any problem with English, we have someone like myself or Marco. We can help to translate Italian to Simon. And you have to change the rooms. Because of that, we finish now. Yeah. Thank you, Simon.
thank you very much.